Okay, so this presentation covers data management, which is the topic of homework 2 and includes big data, database systems, and data storage. Now, granted, this is probably not going to be the most interesting chapter. Fortunately, I don't teach the class on databases and how do you store data because it's not my favorite topic, to say the least. But it's important to kind of have a brief understanding of it for this class prior to getting into how we actually use data to solve problems. So I'll get started. So the era of big data is here. You probably hear this terminology all the time, at least for the past decade, probably from around the last great financial crisis in 2008 on. There's been this talk of big data, which generated these new jobs like data scientists, etc. And now we're getting into artificial intelligence, but it kind of all stems back from this concept of big data. So the availability of data has grown exponentially due to social media and mobile apps, leading organizations to adopt data-driven decision-making strategies to be more productive. In fact, companies that adopt these analytic strategies have generally seen at least 6% higher productivity. Having lots of data is a high asset and a huge liability, so having a method for managing the data is essential. So you can see all these big data sources and how do you store all that data? It's going to have to be in some kind of infrastructure like a data warehouse, data mart, um, database, etc. But you can see, we got your smartwatches, cars, your phones, sales, mouse clicks, anything you do on the internet, uh, how things are being uh, transported across the country, security problems, um, smart key system, smart lighting system, etc. All of this is creating lots and lots of data, and it's coming from lots of different sources. So, and it's structured and unstructured, like we talked about in the last chapter. So that's kind of the era of big data, and it continues on. So what is big data? So you're going to hear the what is it up to now? 5 V's. You started with 3 V's, in the beginning, and now it's up to 5 V's. So probably important for homework. So definitions of big data. Big data has several key characteristics for classifying it, such as volume, variety, veracity, velocity, and value. The basic definitions for these terms are on the slide above, or slide presented, but we discuss them in more detail on the following slide. So, uh, yeah, so interesting. The terminology is changing from big data and adopting smart data, probably because of all the smart solutions that we have these days from you know Alexa or Google enabled devices. Anyways, so characteristics of big data. The volume of data collected by a company can be huge. This volume of data is being used to show a customer's complete journey with the company. Consider Amazon, considering everything you have ever bought and the recommendations they make. The variety in the data indicates that it comes in many types, which can be structured or unstructured. You can also think of social media, which has text, videos, and pictures, which is unstructured, as well as categorical data to frame your personal experience. Veracity is the complexity of the data, and this complexity leads to reduced confidence in that data, which can lead to embarrassing dilemmas for companies. So a good example of this is if someone borrows your computer to look something up, it will create erroneous information, right? Velocity refers to the speed at which the data is coming in, making it both possible and difficult to make real-time recommendations. So to create value, the data must be converted into quality insights that provide real benefits to the company and hopefully to the consumer as well. Managing the data in a database allows the data to be stored and analyzed to provide real value. A relational database stores data in rows and columns. So it's kind of like similar to an Excel spreadsheet, but what if you had multiple Excel spreadsheets that you had a column of data in order to relate those two? So that's called, your primary key and your foreign key once you get to learning more about SQL, et cetera, on, databases. But that's kind of the underlying theme of what a relational database is you have these multiple tables of data and how you link them together, and then you write these queries so you can pull the data from the database that you want. So these columns contain features, predictors, and variables, and the rows have a unique primary key that allows you to identify a particular row of data. But you use that primary key to link between two different tables. So the language used for relational databases is called the Structured Query Language, or SQL. Kind of funny, some people say SQL, but if you go and look at what the original developers of SQL, they say they intended for it to be called SQL, and they don't like it when people call it SQL. But the odds you'll ever actually meet those people are probably pretty nil. But SQL can be used to join, select, manipulate, retrieve, and analyze data in a database. So since then, we have new kinds of database systems. So non-relational database, but I mean, there's a lot more kinds of database systems that have been developed as of recently. You've probably heard of like what MongoDB or NoSQL, which stands for not only SQL. But there's other ways of storing data out there beyond the relational database. But non-relational databases can store both structured and unstructured data and allow for more flexibility. So most companies use both types of databases, but this makes the maintenance and storage of the data increasingly complicated. So enterprise data architecture. So data storage architecture allows companies to organize and use their data, but this requires the right type of architecture to be chosen. The types of data repositories, including CRM, ERP, OLTP, and others. Um, you probably heard of like Salesforce, customer resource management, or customer relationship management. Um, their Salesforce database system to keep track of customers. So that's more of like a marketing or maybe possibly an HR system. We do have another course here on Salesforce that I think we're teaching over the winter this year. It's an online course that we have developed with another consulting firm who's an expert on Salesforce. But CRM is, I believe, the ticker symbol for it. Oh, well, I digress. Also, enterprise resource planning. Um, you may have heard of ERP systems with respect to decision support systems or operations management. So that's kind of a different direction. And online transaction processing, OLTP, you'll deal with when you're like, best example I can think of, let's say you are pulling data from an SQL database down to your private computer via the internet, so you can analyze that data on your computer in an Excel spreadsheet if you're doing, kind of a low-level analytics job. So on another note, data storage can combine the internal data that companies have with outside sources like social media. So streaming data is when data is coming in at a continuous transfer from multiple sources in multiple formats. So ETL is a process where data is consolidated from many sources into one location. So it stands for extract, transform, and load. The first step is to extract the data from the source and convert it to the correct format. The second step is to transfer the data, which requires it to be converted to the appropriate format for storage. The third and last step is to load the data into the storage system, like a data warehouse, data mart, data lake, etc. So Hadoop is an open source software used for big data that divides it among multiple computers to handle the data simultaneously at a reduced cost. This is a bit outside of the scope of this class, but they are good words to know should you go into data management. I used to previously have an assignment where you learned about Hadoop, and there's a IBM certification, I believe. It used to be free, but I don't know. I quit requiring it in this course because you should be learning about Hadoop in the database course. Okay, so this is, I guess, a nice visualization that shows the architecture of the data repository. If you're a visual learner, it may help you to see it depicted in this way. So you have basically all this data coming in from various sources. You know, you have your CRM or ERP databases, you got streaming data from social media, we have data coming in from web applications, typical websites, and other things such as, you know, the Internet of Things, so like smart light systems or smart sensors. It comes in, it gets extracted using Hadoop. It gets, uh, well, better organized for going into a data warehouse, typically. And then on the far end, you have analysts who will then, you know, query this data, pull it in to make visualizations or develop models on it, et cetera, et cetera. So my class and all my classes tend to focus more on these steps past, you know, collecting the data and putting it into a storage system. All right, so a closer look at data storage. So there are several types of data storage, some of which are explained here. A data warehouse provides storage for historical data in a format that is good for high-speed queries. So this is good for order history or looking up basic information. Back when I worked at the hospital, we had a data warehouse that stored all of our, you know, insurance and billing type information. And when I worked in the revenue cycle, I had to write SQL queries to pull that data down first. And once I had the data, I would, you know, do some analysis on it, develop the reports that I would send out to, you know, like the CFO or vice president of finance, et cetera. The other cool thing about this concept of the data warehouse is we had two mirrors of the data, and one would go down to be refreshed, and we'd always have an active one, and then you would go back and forth between these two basic forms, so you never had to worry about, you know, losing all the data or something bad happening. Because if you have heard anybody that works with SQL, if you write a bad query, you can crash the whole database because it'll take up too much time, and it's bad. So basically never do anything like select star all, because on a big database that'll definitely crash it. Anyhow, so a data mart is used for a specific group of users, either dependent or independent. So that's kind of what I was, so from the data warehouse, you could have a subsection of data that you sent only to the people that were interested in, you know, in this insurance data. So in the hospital, you know, there's the clinical data on one side, and then you have like billing data, and I'm sure there's other kinds of data, but that way only you kind of limit the amount of data that somebody can access, which saves time in like query time. Data lake provides storage for large amounts of data in its native form, meaning it isn't transforming it. So data management is the term used for the entire process from acquisition of the data to the disposal of the data. So a huge challenge of data management right now is that the inbound data is increasingly exponential. Data quality. So while there are always many stories about the success of the use of data in decision making, that is not a universal truth, and many companies do not have the same success. The term that is most often applied to data quality is garbage in, garbage out. I'm sure you've heard that term before. Meaning that if your data is not of good quality in the first place, you cannot get good results from it, and the analysis will be unreliable. So the most common dimensions of data quality are timeliness, completeness, accuracy, consistency, and format. Timeliness refers to having real time, or at least the most recent data. Completeness is whether or not you have all the information you need to answer your question. Accuracy is the data is correct, reliable, and accurately measured. Consistency refers to having the same measurement across the data form. And format is how the information is presented and if that method is useful. Data understanding. So the process of exploring data begins with understanding, preparation, and transformation of the data. This is often a time-consuming process, but can be enjoyable, almost like a game, as you consider what questions the data could be used to answer. However, in order to use the data for analysis, you have to clean it up first. So, like I said, data cleaning is generally the most time-consuming process of the whole analytics process or cycle. So understanding the data you are looking at is key step in the analytics process. It is easy to be overwhelmed when looking at a large data set and miss some of the fields or not realize that some data is missing. It is key to take the time to understand the data, determine what actions and analysis need to be taken, consider other questions that could be answered with the data and other aspects of the business problem or problem the data might address. So if you've ever used Excel, like in a business sense, you may have run across issues where there's NAs in certain fields, and that can screw up calculating, like some of the descriptive statistics that you can do in Excel, and that creates problems. So you have to go in and remove the blanks and NAs and kind of filter the data out to make it to where you can calculate the metrics you're looking for. So that's kind of an example of very low level cleaning. Once we get to using R, Python, there's scripts you can write that will automatically clean your data for you, which will be nice. But kind of at the beginning stages using Excel, it's a very manual process. Not that you can't write it in there's another language called Visual Basic for Applications, or VBA, that you can build macros with that hypothetically could be used to clean the data, but we're going to learn much better ways of doing things in the next 4 classes with me. So next, the data needs to be prepared, and this takes time. So you must select the appropriate features or variables that you are interested in, or you think might make good independent variables for like a prediction algorithm. Then you must select the appropriate sample size. So hopefully you have a pretty good statistics background, and you'll know that you'll have to look at the power of the test and what sample size you need to get significant results. So we're going to come into that in the future. A lot of our tests are going to be interested in significance value or the alpha value of less than 0.05. Hopefully that rings a bell. But we can talk more about that in the future when we get to it. So the needed sample size to have a sufficient level of precision can be determined using a power calculation, like I was saying. So the unit of analysis must be determined, and data must be aligned to fit that unit. Missing values must be dealt with. Imputation, omission, and exclusion are ways to deal with that. You can either delete the row of data, or you can put in an average in that missing blank part of the data. There's different ways. It really depends on how much sample size you have. And then outliers must be identified and dealt with as well, because a lot of our algorithms will be easily skewed with outliers. Data transformation. So next, the data is transformed, and there are several steps in this process. Aggregation is when data is calculated into something else, like transforming daily sales to monthly sales, etc. Normalization is the process of scaling variables to ensure they are all on the same scale. This is something we'll have to deal with many times, because otherwise, when you get your results from an algorithm, if they weren't scaled together, whatever the highest value of the independent variable that you're putting in will end up having a higher weight and affecting the dependent variable more. So that's why you have to scale your data. New columns can be created by breaking up information into new categories. You could also do something called dummy coding, where you use a binary variable um, to represent some kind of like nominal or categorical variable. So we'll get into that and potentially in this class, but definitely in future classes, because there's other problems that can occur when you start using too many dummy variables. I think that's it. So this is the end of the presentation on data management. This presentation covers the material found on homework 2. So best of luck.